Graphing a quadratic function, we come out with a parabola, and a quadratic function is written as ax squared plus bx plus c. And when we call it a function, we need to name it. It could be f, h, q, g, whatever you want, but in this case I'm going to call it f. And we have an order in which we need to process. So if a is greater than 0, meaning positive number, right? Then this parabola, because that's what a quadratic is going to show. It's what's going to be what's drawn on a graph is a parabola. So if a is greater than 0, then it's a positive number. That means it's going to open upward. If a is less than 0, then that means it's a negative number. That means this parabola will open downward. So when we look at it, that's one of the things we want to first establish. So I got this function of f of x equals 2x squared minus 4x. And I'm going to determine if it opens upward or downwards because it's going to help me to graph it. So what is a? A is 2. Oh, it's positive. So I automatically know this parabola will open upwards. Next, I want to find the vertices. Vertices is basically the belly of the parabola, right? It can also help us determine what's the axis, the symmetry, or the axis of symmetry. So let's do this. Let's see. We have a vertices. And our formula is going to be x comma y, which is, or excuse me, my order pair is x comma y, which is going to be replaced with h comma k. And h is equal to b, negative b divided by 2a, comma, f of negative b over 2a. So basically means whatever I find for h, I'm going to plug it back into the function, and I'm going to know whatever my k is. So h is negative b. Well, what is b? Well, b is negative 4, right? Because we got it written in that order, the descending order. And then a again is 2, and let's solve for it. So now I got negative 4 divided by 2 times 2 is 4. Negative times negative is a positive, right? And then 4 divides 4 is 1. So this worked out nice. H is equal to 1. So I'm going to take my function and I'm going to plug in 1 for x. And in this case we're calling it h. And it's going to give me what is my k, which is also my y. So we got 1 in the place. 1 squared is just 1 times 2. Negative 4 times 1 is negative 4 plus 5. 2 minus 4 is a negative 2. Plus 5 gives me a positive 3. So my vertices order pair is 1, comma 3. So when I go graph this, this is the belly, right? This is going to be this particular point of the parabola. So we can go ahead and graph that point here in just a minute, but what we need to do is to determine the axis symmetry. We want to know what that is, and in this particular case, since that's the belly, the center of the parabola, right? When I draw a line through it, I'm going to know what that is, and it's a vertical line. That means x is equal to 1. So my axis of symmetry is x equals 1. Next, I need to find some order pair, and the best way would be first to graph to see where it falls, to see if I'm going to have an x-intercept, and then I can solve for a y-intercept as well. But let's go ahead and do the y-intercept first. Y-intercept just clearly states that x will always be 0. So if I do that, and plug in 0 for x, I'm going to automatically know what the y-intercept is. So let's plug in 0 for x. And of course 0 squared is 0 times 2 is 0, 0 times -4 is 0, and that just leaves me with 5. So my y-intercept is 0, 5. So I got this point I can graph, this point I can graph. I know what my axis symmetry is because this is the center of the parabola. And I have, I know this, so I know it's going to open upward, so it's going to help me with my x-intercept. So let's plot this. Here is my form. So we have the vertice is 1, 3, right? We know the direction of the parabola because it's a +2 for A. It's positive, so it opens upward. I know my axis symmetry since the vertice is the center of the parabola, then that means whatever x is, because it's going to be a vertical line through it, it's going to be 1. So let's plot it. We start at 0, 0, and we're going to go over to the right 1 because x is positive, and we're going to go up 3 because y is positive. 1, 2, 3. If they were negative, of course, we'd fall on the negative side, right? This side here for x is positive. This side here for y is positive. This side here for x is negative, and this side here for y is negative. So it's important that you understand that. So now I have my vertice, and we also solved for our y-intercept. I don't see it on my list here, but my y-intercept is going to be an order pair of 0, 5. So let's come over here and plot that. So we're going to start at 0, 0, and we're going to stay on the y-axis because it is y-intercept. 1, 2, 3, 4, 5. So it's opening upward, right? So I know this much about it. That means this other side's going to come up this way. Then that means that there is no x-intercept. It's not going to cross the x-axis, right? Because it's opening upward and this point is above it. If it was down here below it, we would cross it. But in this case here, it's not. So there's no sense doing that extra work. But what we do need to do is find the order pair on this side of the vertex in order to see which way it's going to go. So if x is 1 right here, let's use 3 for x and plug it into our formula, our function. And let's find out what the y value is. So now I have 2 times 3 squared, which is 9, minus 4 times 3, which is 12, a negative 12, plus 5. 2 times 9 is 18, minus 12 plus 5. 18 minus 12 is 6 plus 5, which gives me, what, 11? Right, 18 minus 12, yep. Okay, so it's 11. So we're going to have to go up 11 for it. So I'm going to come over here, 1, 2, this is what? This is 1, 2, 3, go up 11. It'd been better if I would have stuck with 2. It would have gave us a point right here across from it, but that's okay. Just be careful when we draw it. And it's actually going to be above the graph, so it may be easier to say, well, that's going to be above the graph. Let's go ahead and try the 2. If not, you can just be careful that you don't make a V out of this because it's actually a parabola's curve. So let's try 2. Let's try 2 for x and see what that yields. So let's try that. Let's try 2 for x. So 2 times 2 squared, right? 2 squared is 4. 4 times 2 is 8. So I got 8 minus 8 plus 5, and what happens? 8 minus 8 is 0, plus 5. See, that worked out great. So now I have an order pair of 2, 5. So let's go to 2, and let's go up to the 5th for, so that worked out better. We're not above the, just be careful, don't make a point, make sure it's curved. So now I got my graph. So my order pair I would have put here is 2, 5. It made it easier because if I did 3, I would have to make me some point right here because this is a 10 by 10, which is okay. You just have to be careful when you draw it. So 2, 5. And the domain of the parabola, well, since I have arrows on each end of this parabola and they're continuously going out like this, that means that my domain is all real numbers, right? All real numbers for x, because your domain values is your x values. My range, though, is my y values. And I noticed that my y started right here. Right? The belly of the parabola is right here. So whatever y is here, right? I'm going to put a bracket on it because it included it. It's 3. That's what my y value is there. And then I noticed that there's an arrow on at least one side of these. That means it's going off to infinity. And then my function is graphed. I got my range, my domain. I know my needed order pair. I know what my y-intercept is, and that went with the order pair. Now, let's just plot our axis of symmetry. It's going to be what splits this parabola in half, and like I said, it just so happens to be a vertical line, which means x is equal to whatever that point, and that's 1.